Hello everyone and welcome to yet another math video. In this video, I will go over how to solve absolute value inequalities. You will solve absolute value inequalities very similarly to absolute value equations, but you got to keep that one twist from linear inequalities in your mind. That one twist being that if you multiply or divide by anything negative, then you will change the direction of the inequality sign. I will also assume that you have some knowledge on how to solve absolute value equations and linear inequalities. So in order to understand this, I will teach this similarly to how I teach solving absolute value equations, meaning we have to first isolate whatever's in the absolute values. So that absolute value up here is isolated. Then we get to write down the plus and the minus version of this inequality. Now, because this is an inequality, the plus version will look darn near exactly similar to the inequality that was given. The minus version, because that 2 was flipped to a negative, the inequality sign will swap directions. And lastly, since this was a greater than, the absolute value was greater than a number, this will introduce the or between these two inequalities. So to solve this, we have to solve an or compound inequality. And we really don't have anything to solve for here because u is already solved for, but we can put this into set builder notation since the variable is u. We will say that u is the solution for that inequality up here, as long as u is greater than 2 or u is less than 2. I realized the mistake up here. There is no equal to underneath that second inequality. Okay, don't forget my curly brace. The graph on this one, we have two numbers. Right? We have a 2 and a negative 2. They both get open dots. And what happens here is u is less than negative 2. So this will go to the left. Put my infinities here. We're going to need them. And this u being greater than 2 means it starts here at 2 and goes to the right. All right, so that's what the graph looks like. Now, interval. With the intervals, because there are 2 of them this time, we have to list both of them out. So negative infinity to negative 2 and 2 to infinity. And the way to join together two inequalities by or, but in interval notation, we will put a u between them. That is a union. So or union. And those are the answers for all of those. The inequality answers, again, are just up here as u is greater than 2 or u is less than negative 2. Okay, with this next one, w is less than, the absolute value of w is less than or equal to 4. So we can split this apart again. 1 plus 1 minus, that goes in front of the number. But remember, for that minus one, the inequality symbol changes direction. Now with an absolute value being less than a number, this creates an and inequality. You don't have to smush these together into a single inequality, although you can. And I'm going to explain how to by looking at the graph. So what I will do is I will enlarge the graph up here, and I will say we have our two numbers, -4 and +4. Since they both have an equal to, that means they will both get closed dots. And what's happening here, you can see, is that W has to be less than or equal to 4, which means it shades to the left of 4. And W also has to be greater than or equal to -4, which means it shades to the right of -4. And the question becomes, where is the overlap? In the overlap, I'm going to mark in a different color, you can see is right between these two numbers. So we could, if we wanted to, write these out as -4 is less than or equal to W is less than or equal to 4. So that's how you can understand it as a single inequality. Most times you do not need to make that jump, but if you do, I would say graph it, find the overlap, and then change it to a single inequality like this. The graph I'm going to put down here for the answer will be -4 to 4, again, both with solid dots, but only shaded between. The set builder can be done with either of these notations as far as I'm concerned. Again, you'll have to listen to whoever's teaching you math. So W is long as W is less than or equal to 4, and W is greater than or equal to -4 with curly braces around it. And then the interval here from the graph would be -4 to 4, both with square brackets around it. Okay, all that work done, I'm going to move on to 2 more examples. So let's get these completed as quickly as possible. Before I get these done, take a moment, rewind the video if you need to, see if you can determine whether or not these inequalities will be and or related. Okay, I'm going to start with example 4, and we can split these apart just like we've been doing, 1 plus 1 minus. So without the absolute value, this will be exactly the same as the original inequality, just without the absolute value. This other one, 5 minus 2W, is greater than -15. That will be the other inequality, and this will be an and inequality over here. Less than, an absolute value less than a number, and. Okay, so we can solve both of these for W. To get W is greater than 5, -5, and that W is less than 10. And yes, these inequality signs will switch or change direction because there is a -2 being multiplied to W, and eventually you will have to divide by that. So the set builder notation here will be W as long as W is greater than -5 and W is less than 10. Oops. There we go. The graph here, if you need to take the time to draw the double graph and see where they overlap, that's fine. Go ahead and do that. but for the time being, since this is an and inequality, it'll be shaded between these two, which then makes the interval notation much simpler. So these are the answers you should get for example 4. Backtracking to example 3, we can have a plus and a minus with an x minus 8 is greater than or equal to 2. In this case, it's an or. X minus 8 is less than or equal to negative 2. And when you solve these out, you'll get x is greater than or equal to 10, or x is less than or equal to 6. So that is the set builder notation. It's x as long as x is greater than or equal to 10, or x is less than or equal to 6. And then the graph will be 10 with a closed dot going to the right, and a 6 with a closed dot being shaded to the left. So I need my infinities here, negative infinity on the left side, positive infinity on the right. I can see two intervals here. The or, remember, translates over into a union in the interval notation. So this would be negative infinity to 6, union 10 to infinity. That's it. Last example complete. Thanks for watching. See you in the next one.